Myself, Madhukeswara RS, Assistant Professor of Physics, Government College for Women, Mandya. Dear students, I have come up with a new idea to make your learning process easy. That is, knowing physics by solving problems. Here, I have taken two concepts to explain the same. Number one, the de Broglie concept of matter waves, and the second one is the Compton effect. To explain the de Broglie concept, here I have taken two problems. One is on the electron and the other is on the cricket ball. So if we calculate the de Broglie wavelength of an electron moving with velocity 2 into 10 power 6 meter per second using the de Broglie wave equation, that is lambda is equal to h by mv, you will get 33.15 into 10 power minus 6 meter. On the other hand, if we calculate the wavelength of a cricket ball of mass 150 grams moving at a speed of 20 meter per second, the de Broglie wavelength lambda is found to be 2.21 into 10 power minus 34 meter. In the first problem, the mass of the electron is insignificant. So that's why the wavelength is significant. But whereas in the second problem, the mass of the cricket ball is significant. That's why its wavelength is insignificant. That is, if mass is insignificant, then the wavelength becomes significant. Hence, one can observe the de Broglie wavelength of an electron. If mass is significant, then wavelength becomes insignificant. Hence, the de Broglie wavelength of cricket ball is not observable. Therefore, just by solving these two problems and comparing their wavelengths, one can understand the de Broglie concept. According to de Broglie, a material particle moving with velocity v behaves like a wave, and the wavelength associated with a moving material particle is given by lambda is equal to h by mv. It is one of the beautiful relation in physics because which connects the wave parameter such as the wavelength with the particle parameter such as the momentum. Therefore, the concept is significant for a microscopic particle like electron and not for a macroscopic particle like cricket ball. Now let us consider the next concept, that is the Compton effect or Compton scattering. The wavelength change observed during Compton scattering, which is called Compton shift, delta lambda is given by lambda prime minus lambda, which is equal to h by m naught c into 1 minus cos theta. So now let us consider a problem on Compton shift or Compton scattering, in which an X-ray of wavelength 0.18 angstrom is scattered by a carbon target, and we have to calculate the wavelength of the scattered X-ray photon and the corresponding observed Compton shift and the energy of the recalling electron at two different scattering angles, that is at 45 degree and at 180 degree with respect to the incident direction. Now let us calculate the wavelength of the scattered photon, the Compton shift the energy of the recoiling electron for theta is equal to 45 degree. So in order to find the wavelength of the scattered X-ray photon, one can write the expression for lambda prime as lambda plus h by m naught c into 1 minus cos theta. In the given problem, the value of lambda is 0.18 angstrom, and for the first case theta is 45 degree. If you substitute those values along with the other constants, you will get the value of lambda prime as 0.187 angstrom. Then for the same scattering angle, if you calculate delta lambda, we'll get 0.007 angstrom as the shift. And if you calculate the energy of the recoiling electron for theta is equal to 45 degree, it is found to be 2.585 keV. And for a scattering angle of 180 degree, the value of lambda prime is 0.228 angstrom and delta lambda is 0.048 angstrom, and the energy of the recoiling electron is 14.53 kilo electron volt. Therefore, if you compare the value of lambda prime for theta is equal to 45 degree or for theta is equal to 180 degree with that of the wavelength of an incident photon, it is clear that the wavelength of the scattered photon in both the cases is greater than the wavelength of the incident photon. Therefore, which concludes that the Compton scattering is an inelastic scattering, because here we are observing that the wavelength of the scattered photon is greater than the wavelength of the incident photon. That's why it is an inelastic scattering. Therefore, you can know the nature of the scattering just by solving a problem. And it is also observed that the value of delta lambda for theta is equal to 45 degrees, 0.007 angstrom, and whereas for theta is equal to 180 degree, the value of delta lambda is 0.048 angstrom. That is because according to the expression, the Compton shift, it depends only on what? The scattering angle. As the scattering angle changes, delta lambda also changes. That is, the increase in theta value increases the value of delta lambda, which lies between 0 and a maximum value of 2h by m naught c for theta is equal to 180 degree. Therefore, the Compton shift, it depends on theta, can be observed by solving a problem like this. And if you compare the values of the recoiling electron, so in the first case, that is when theta is 45 degree, it is 2.585 kilo electron volt. When theta is 180 degree, it is 14.53 kilo electron volt. So that is because, again, the energy transferred to the electron, it depends on the value of delta lambda, that is Compton shift. As Compton shift increases, the energy transferred to the recoiling electron also increases. So that's why, the value of the energy of the recoiling electron in case of 180 degree is 14.53 kilo electron volt. But whereas in case of 45 degree scattering angle, its value is 2.585 kilo electron volt. Now, let us calculate the energy of the incident photon using the relation E is equal to hc by lambda. And that is found to be 69.06 kilo electron volt. And if you compare this value with the energy of the recoiling electron for theta is equal to 45 degree or for theta is equal to 180 degree, it is clear that the energy transferred to the electron is always less than the energy of the incident photon. That's why a Compton scattering is an inelastic scattering, means in which the photon will not transfer its complete energy to the electron at rest, because Compton scattering takes place when an energetic photon interacts with an electron at rest, or when it interacts with a free electron. If the electron in a free state cannot absorb the complete energy of the incident photon, because in that case the law of conservation of energy and linear momentum will not hold good. But whereas if we consider a low energy interaction such as a photoelectric effect, in that case the interaction of the photon is with the bound electron. Therefore in that case the electron can absorb the complete energy of the incident photon. But whereas in case of Compton scattering, the interaction of a photon is with a loosely bound electron or with a free electron. So that's why the electron will not completely absorb the energy of the incident photon. See students, how one can understand the entire mechanism of the Compton scattering just by solving a problem. You may be wondering that why I have chosen these two concepts, that is Compton scattering and de Broglie concept of matter waves. Because the Compton scattering signifies the particle nature exhibited by light, which is basically a wave, and we know that light exhibits a phenomenon like reflection, refraction, interference, diffraction and polarization. In such cases, they treat light as what? Light as a wave. But whereas in this case, it exhibits the particle nature. Hence, it signifies the particle nature exhibited by light. The same thing can be observed even in case of a photoelectric emission. On the other hand, the de Broglie concept of matter waves explain the wave nature exhibited by a moving particle. Okay, in the first case, a wave behaves like a particle, but whereas in the second case, a particle behaves like a wave. Students, you can replace your pressure by a pleasure by enjoying the physics concepts while solving physics problems. Next week, I will come up with a new idea. Till then, take care of your health. Thank you.